Today we're going to look at a few more geometric proportions. So the first theorem that we're going to discuss is the side splitter theorem that says that if a line is parallel to one side of a triangle and intersects the other two sides, then it creates similar triangles. So we have a line right here that's parallel to one side of the triangle here, and we know they're parallel from the arrows, and it intersects the other two sides, so it creates similar triangles. So the smaller triangle is basically the top. We have X, 20, and 12. The larger triangle has a base of 25. The right side is the 3 plus the 12, so 15. And the left side is X plus 4. So the proportion that we would set up is X over X plus 4 equals 20 over 25. Or you could use the 12 and 15, it really doesn't matter. We'll cross multiply and say 25x equals 20 times that whole thing. We'll distribute the 20 into the parentheses. So 25x equals 20x plus 80. Subtract the 20x from both sides and get 5x equals 80. So x equals 16. A corollary to the side splitter theorem is that if three parallel lines intersect two transversals, then the segments intercepted on the transversals are proportional, which means that each of the pieces is proportional. So we would say 8 over 14 is equal to 12 over x. Cross multiply, 8x equals 168, x equals 21. All right, and then last but not least is our triangle angle bisector theorem that says that if a ray intersects, or bisects, an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides. All right, we need the ray to bisect the angles of the triangle, so we need to make sure that we see these congruent angle marks so that we know that the larger angle has been bisected. And then we can go ahead and set up the proportion. We would say that 8 over 20 equals 6 over x. Cross multiply, 8x equals 120, x equals 15. All right, let me know if you have any questions.